This is my Geology 110 summary. Science of disasters. I thought the three important things about science of disasters was hazard, disaster, and catastrophe. I put an example of what a catastrophe damage could look like, and it's about an 8.0 magnitude of earthquakes. It's like one of the highest earthquakes that we could get. A hazard is a naturally occurring. It also affects on humans. Disasters is effect of a hazard on society. It usually damages property, injuries, or even loss of life. And then a catastrophe is a massive disaster. So I thought that the locating of earthquakes was probably the most interesting. The epicenter, the focus. The epicenter is actually on top of the focus. The Richter scale is what we measure with for earthquakes, and then the seismometer. It measures the P and S waves. The P waves come first, and then the S waves come second. This determines the distance of the earthquake. And the magnitude is based on a 10 times scale. So if it's one, you gotta do it by 10. To be considered, I thought that the average amount of slip along, area ruptured, rock strength, and most accurate measurement were very important with locating earthquakes. Volcanoes, I thought that the volcanic hazards of volcanoes was probably the most important. Lava flows, they provide nutrients for the soil, which I didn't know, so I found that interesting. They have lava bombs, they have pyroclastic flows, ashfall, which also provide nutrients for soil, poisonous gases, and lahars. And I didn't know that there were so many different types of hazards that come with volcanoes. Climate and weather. So the climate is atmospheric conditions of over a long period of time, as weather is a short period of time. I did the geosphere, hyosphere, cryosphere, and biosphere and atmosphere just to see the different types of spheres that are in our on our Earth and what we use. I did atmosphere because that relates to the climate and weather. Deadly weather, blizzard, hailstorm, hurricane, tsunami, tornado, and I did storm surge because I studied that a little more in class. So the seawater crashing onto the beach, flowing onto roads, usually a rough storm, active ocean. As you can see that picture right here, does a pretty good example of a storm surge, and then tidal wave as well. Flooding, I did flash flooding versus regional flooding. Flash flood is higher elevation and is also a sudden intense thunderstorm that overwhelms a watershed. So this is just like all at once, like the flash flood just comes out of nowhere, just like fills up and runs down in higher elevation. And then the regional flood is actually in lower elevation, but it's long drawn out rain. And then the tributaries feed into a larger river to overwhelm major rivers. So this it just keeps going, flowing down, and ends up in a major river, which overwhelms it as well. And then we've got groundwater. So I thought the contamination of groundwater was important because I'm a big eco person, and I totally support less water usage and recycling and everything. So I thought the contamination of groundwater problems was very interesting. There's industrial waste, there's animal waste, there's human waste like E. coli, pesticides, herbicides, pharmacies. The pharmacies dump their chemicals and medication into our ground and it gets into our groundwater. And then we got subsidence, which is the Earth's fissure and basin and range. Subsidence actually is the pumping out of water faster than replenishing. Earth fissures is a differential subsidence, so it actually creates unstable homes and roads, which is important for people to know. And then they also use them as a garbage dump, which isn't okay. And then the basin and range is an extension-led series of normal groundwater overpumped. The spaces fills, which causes it to sink, actually, which is really sad. And then the causes of subsidence is the overpumping of oil, overmining. It could be from sinkholes, and then overpumping of groundwater. And then ocean currents and climate change, they are related to each other because of the conveyor belt, which is a circulation of oceans, as you can see right here, as I showed you. So the red one is the warm surface flow, and then we got the blue one, which is the cold surface flow. These are the two ocean currents. We've got the Atlantic Ocean, which is the strong northward movement of near surface waters are cooled when they arrive near Greenland. And then we also have the water cools, which makes it saltier and denser, which makes it sink, and then flows southward around Africa, as you can see right here. And then my favorite subject was the beaches. I thought beach budget was really interesting because, like I said, I'm huge on conservation. I'm huge on making the earth a better place, and I love being next to the beach. I went to Santa Barbara last year, and my school was right next to the beach, so I really enjoyed that. The dams are not as popular, and then we've got ballast, which is boulders that help block, and then we've got beach nourishment, which also is a huge plus. And the dams actually prevent sediment from carried downstream. And then we also have the ballast, which is the boulders that stop erosion. They usually don't leave a lot of beach left, which is not the good thing about that. But beach nourishment is the sand pumped onto the shore. It's probably our best bet, but it's expensive. And then the groins and jetties is trapped sediment on one side, and then they causes erosion on the other. The importance of geology to humans is that everything we utilize is from Earth, so it's important to know like what we're using and how we're using it and how much we are using of, because the Earth will keep replenishing, but at the same time, we can't use up everything that it's giving us. Study of Earth processes like natural disasters can affect civilization overall, so it's important for everyone to know the hazards that come with natural disasters. Or else they could be in a lot of danger. And then I only had one citation. Thank you.